Hello, my name is Jason Poole, and I work in the Application Security PMM team at Citrix. Today, I want to tell you how you can use machine learning to protect your applications from cyber threats faster. Point of note, as we go through this presentation, there'll be you may well have questions, and there's a Q&A panel. Just ask your questions in there, and we'll have a team of experts on hand to answer them. So machine learning is the new computing paradigm. It's the latest buzzword in the IT industry, promising to solve all the woes that we face. Just about everything out there is now listed as machine learning based or AI in some form or other. Well, machine learning is very real, and it does deliver on many of its promises. It does this because it allows us to process massive amounts of data very quickly. And while this idea is not new, nor are the theories or algorithms behind it, its sudden appearance and rapid growth is. The democratization of machine learning has come about because of the abundance of cheap compute power on demand available from the cloud. In the past, machine learning and AI was restricted to governments or organizations with very deep pockets who could put together the necessary compute resources to process the data required at scale to make meaningful impact on a problem. Machine learning allows computers to infer from experience and spot anomalies very quickly, even to identify correlations and see what can't necessarily be seen by other scenarios. Most importantly, it helps us make predictions about future scenarios, which helps us stay ahead of the curve, which can be the difference in cybersecurity. In today's talk, we'll look at some of the machine learning use cases that we're all familiar with, including common techniques in cybersecurity. We will take a look at the advantages and disadvantages before turning our attention to the differences between machine learning and traditional programming approaches. Next, we'll take a look at how Citrix uses machine learning to analyze application telemetry to identify anomalies and spot attacks. Lastly, we'll look at what this might mean for your approach to application security overall. Machine learning is all around us. There's so many examples of machine learning in everyday life, things we are all familiar with that wouldn't exist without machine learning. Voice recognition, for example, all your home assistants, they process voice using machine learning. The recommendation engines in Netflix and Prime and others, they recommend movies or products based on your previous choices, and they use machine learning to do this. Usually credit scores are used when you want to apply for credit, but when that's not available, machine learning can help by looking at other factors like your current financial health and your habits, and that's useful for people requesting credit for the first time, for example, students as they graduate. And there are many sites out there that use machine learning to track pricing for air travel and hotels to offer consumers the best deals. And search, of course. Google aside, Quora uses machine learning to determine which questions are most pertinent to a user's search query. They look at account thoroughness, truthfulness, reusability, and other characteristics to get the best response to any and all questions by their account. And ranking posts in social media. Originally, Twitter posted the most recent post at the top of each user's timeline, but then switched to machine learning to determine which posts would be most relevant to each user and rank things accordingly. And of course, translation services use machine learning to improve their efforts. And Duolingo recently tried to gamify language learning by developing an understanding of how long it takes before a word needs to be refreshed using machine learning, and then it presents it to the user again. And it's been used for a while in the security industry. You're probably most familiar with it in the realms of blocking spam. I'm sure that Gmail and other large mail providers use it to protect their customers. Just the volume of mail that they get, it's pretty easy to analyze it and say this is spam and this is not. And it's also used in financial fraud detection, spear phishing detection, and DDoS prevention. But machine learning is not a silver bullet for protection, however. Bad actors can use machine learning for nefarious activities too. While security experts use it to process large amounts of data to perform behavioral analysis to speed up detection of cyber threats and spot anomalies more quickly, so attackers are using machine learning to enhance their offensive plays. They use it to try to bypass captures, leading to the escalating game of cat and mouse that we all play when we're logging into a site. They use it to improve credential attacks. By generating password lists that are related to a user, they're able to crack accounts open faster. Malware can be crafted to evade detection through the use of machine learning. A recent paper I read talks about using machine learning to change the malware to evade detection in up to 45% of cases. And that has some pretty serious repercussions, though it's not yet seen in the wild, thankfully. And advanced phishing, yes, as we mentioned in the last slide, it can be used to protect, but also to improve the efficacy of attack. Using machine learning to improve research on a victim, which can significantly increase the chances of a click-through and improve the likelihood that the phishing attack will be successful. Ultimately, I think you need to understand that businesses have to be aware that the adversaries have these tools, and you need to match them. This, coupled with the severe lack of cyber skills in the industry, currently mean that machine learning may be the only viable option for security in the future. But it's not all plain sailing with machine learning, however. Yes, on the plus side, it helps you identify trends and patterns from large volumes of data for faster anomaly detection. Moreover, it can also pinpoint causal relationships between events. And yes, it does help you automate your security with little to no human interaction needed. And yes, by giving the machines the ability to learn, we also give them the ability to make predictions and improve the algorithms they use on their own account to become more accurate and more efficient, which leads to better decisions. And yes, machine learning algorithms are also excellent at dealing with multidimensional and multi-variety data, even in dynamic or uncertain environments. And yes, if you find the right algorithm and train it correctly, you can apply it almost anywhere. It can be used in a wide range of applications, from healthcare to cybersecurity, even to retail customer experience and beyond. But there are disadvantages. Machine learning can take massive amounts of data to train. And this data also needs to be inclusive and unbiased and of good quality. The compute requirement is not small either, to say the least. Also, the time to train a model can be a factor. Interpretation can be tricky. You need to make sure you're using the right algorithms. And to minimize error susceptibility, you do need a large data set for training. And of course, you need to know when to retrain your models or build this into your modeling so that it's continuously being retrained. All that said, I'd say overall it's better to have machine learning for cybersecurity than to not have it. And let's take a look at a hypothetical example. For example, suppose a business has been compromised recently, and what would it take to find out what was stolen, how it was done to prevent recurrence, and of course to repair the systems? Well, if you did this manually, an analyst would need to review access logs, looking for access to sensitive files, or perhaps large amounts of data flowing into or out of the network. To determine how the attack was committed, you'd have to examine the disks and memory of each machine to find the malware using signatures that have been developed by humans. And perhaps you'd need to even analyze running systems looking for unusual processes and anomalous behavior. And all of this is time-consuming and error-prone, as well as adding more people, tools, and costs. With machine learning, many of these tasks can be automated and perhaps deployed in real time. A well-trained machine learning model can identify unusual traffic on the network and shut down connections immediately. Machine learning could also spot new samples of malware that might evade human-generated signatures and perhaps even quarantine them before they execute. Machine learning can also learn what normal operations of endpoints looks like in your environment and determine when things are out of the ordinary. Machines can learn to do the grunt work and free up the security experts to do much more meaningful things. I like to think about machine learning as bringing intuition to computing. It makes the computer think like a human and learn from experience. Of course, machine learning is able to make the qualitative much more quantitative a little more quickly than humans can. So what is machine learning? Well, it's a system of computer algorithms that can learn from example through self-improvement without being explicitly coded by a programmer. It's part of artificial intelligence for sure, and it combines data with statistical tools to predict an output which can be used to make actionable insights. It differs radically from traditional programming. In traditional programming, all the rules of the system have to be defined in advance, and then the computing is carried out following these sets of rules. And as systems become more complex, more rules need to be written. And in cybersecurity, this can quickly become unsustainable. Machine learning, however, takes a different approach. It infers rules based on the correlation between the input and the output data. The programmer does not need to add new rules every time there's new data because the algorithms adapt, and in theory at least, improve over time. Like I said, it's almost like the computer is using intuition. Let's take a look at some simplified examples of machine learning to try to illustrate these points. Computers often learn through the discovery of patterns in data, and a crucial part of that learning is choosing the data to train the machine with. Machine learning can be grouped, I suppose, into two broad learning tasks: supervised learning and unsupervised learning. In supervised learning, an algorithm uses training data and feedback from humans to learn the relationship of given inputs to a given output. And once trained, machines can predict new data based on the new input. And this works very well when you want to classify things into groups. For example, you may use machine learning to train a computer to recognize bananas and oranges. By showing it many different types of the item and defining them, the computer begins to form rules based on some aspect like size or color, etc. And the machine can then make a prediction when shown a new object. And this can be reinforced with feedback. This example shows two items, but it can be extended to multiple classes with the right training, as you can imagine. And staying on the subject of supervised learning, regression is another method in machine learning that attempts to predict a value based on inputs. It's a continuous value rather than the classification. And typical examples of this are trying to predict stock prices given a set of conditions, or the weather forecast based on environmental data. And both of these have a lot of variables and they're notoriously extremely difficult. A simpler example might be working out the value of a used car. You can train the model on sale prices of cars, together with their age, mileage, and a host of other variables like color or condition. But in any case, the computer will take the data and try to quantify the effect of the variables on the final output price. And this is represented with a line of best fit. That is the most accurate line that can fit with the observed data. And it might be that a mile traveled lowers the price by $1, or a year of age by $5,000. Ultimately, the computer will work out from the training data so that when a new example arrives, as in this case here, it sees a new car with different parameters, and then it can extrapolate what a reasonable price for that would be. Now, obviously this graph is only showing one variable and a straight line, which makes it nice and simple, but with machine learning, multidimensional and nonlinear models are extremely common. Of course, all that's fine if you've lots of time and plenty of data to train a model, like you might have with weather forecasting or car prices, but it's a little more difficult with cybersecurity scenarios where conditions will be unique for every deployment, and predicting abnormal traffic patterns for one website will be very different from another. Here you need a different method of training: unsupervised learning. Unsupervised learning is similar to how humans learn, by experience. Models are trained with unlabeled data sets, perhaps even in real time, and the computer looks for the underlying structure in the data set and groups data accordingly. This makes it great for finding useful insight from data, so it's vitally important in cybersecurity, where each business's data set is unique. If we take the same example as before, using bananas and oranges, but this time unsupervised learning, it would go something like this. The computer has shown multiple objects but doesn't have them labeled. It deduces some structure to the data. There are round objects and there are straight objects. And based on these learnings, the computer will sort the objects and classify them, but without naming them specifically. It says, I have a group of round objects over here and a group of straight objects over here. And again, in this example, we're using only a single dimension, but it could introduce color or texture or other things like that. So it can be extended to include many other parameters as well. So how has Citrix taken these new techniques and put them into use for our customers? Well, before we look into that, I think it's best to explain why machine learning is becoming more important in application security. First of all, there are more applications in existence than ever before. Your business is totally reliant on applications, probably. Nearly all processes are underpinned by an application of some sort. And this has tremendous benefits for business operations and agility, but all of these apps are an attraction to criminals, and each one represents a potential vulnerability into your data assets. Add to this that apps are becoming more complex with so many features and advanced functionality that there's always scope for a vulnerability to slip through unnoticed that may be exploited. Moreover, businesses are deploying apps on-prem and in the cloud, and this distributed deployment makes it harder to maintain a consistent security posture with multiple toolsets from different cloud vendors. When you combine this with the fact that there are more attackers, from script kiddies and hacktivists out to cause mischief or make a statement, business competitors and other criminals looking for financial gain from your valuable data assets, to nation states with their deep pockets acting as advanced persistent threats, your business faces a barrage of attackers. And bad actors also see attacks as more rewarding now. There's more really juicy data out there being exposed, and it's much easier to sell it on. And it's easier to launch, and easier and cheaper to launch attacks. The accessible supply of rent-to-hack services on the dark web is really driving the cost down. On top of this, the attackers that matter are launching much more sophisticated attacks. Attacks that mimic normal human behavior and are hence very difficult to spot. And I think the question is not, should you use machine learning to protect your applications? The question really becomes, how can you protect your apps without machine learning? It's too complex to protect apps manually. But in order to use machine learning, you need the data. You can't analyze and protect what you can't see. Citrix has delivered and protected the data assets and application experience of many of the internet's leading web giants and many thousands of enterprise customers for 2 decades or more. As a result, Citrix, and in particular the Citrix ADC portfolio, is in a unique position to see all the application traffic, processing every inbound request and outbound response. And this results in massive amounts of application telemetry. And in the past, that's all been stored as logs for review subsequent to something going wrong. Now, however, Citrix is able to collate the data to Citrix ADM service, and by applying the compute power of the cloud, is able to extract more meaningful insight about the applications and their security. Citrix ADM service can process huge amounts of data very quickly, which enables it to baseline your application performance and interactions so that you don't have to guess thresholds that constitute an attack. Moreover, you don't have to constantly update those thresholds manually as your application conditions change. Citrix ADM can identify anomalies more quickly, including irregularities that humans would not be able to see readily. This helps you protect your applications, but also helps you plan future security capacity. With the sheer amount of data, machine learning is critical for detecting trends and anomalies that are just not necessarily apparent. And Citrix ADM has numerous machine learning use cases in place to help our customers protect their applications and their businesses from attack. I split them into 3 sections here: general purpose machine learning cases, and those that can detect bot violations, and the more specific application detections. I can't go through them all in this forum, there just isn't time, but we'll look at some of them at a high level. On the left there, you see the general use cases are fairly self-explanatory. Server response time anomaly, by continuously tracking the server response times and finding a baseline. Citrix ADM can tell when your server takes longer to respond than would be expected, and you don't have to manually set thresholds. This is very powerful for many of our customers when they're detecting what's wrong with their systems. Application usage anomalies. Similarly, using machine learning, Citrix builds up a baseline of usage for each application and then determines when use is outside expected norms and alerts you that something might be wrong. Another great use case that's very popular with our customers and particularly useful for cybersecurity is monitoring the system resources of the ADC farm and then modeling future requirements that will help you plan capacity going forward. And Citrix prevents many bot attacks with simple filtering techniques based on IP address or signatures or device fingerprinting. But as bot attacks become more sophisticated and their behavior mimics humans, much more complex machine learning techniques are required to spot them and detect them. And similarly for WAF violations. Because Citrix ADC is constantly monitoring so many traffic parameters, it can use machine learning to detect many different types of attack. For example, abnormally large uploads or downloads of data, excessive client connections. All of these could be linked to cyber attacks. And Citrix continues to expand the use cases for machine learning and will introduce character-based anomaly detection, which will help protect against zero-day attacks in web applications in the near future. Let's take a closer look at some of the other types of machine learning use cases. Now, for the record, I will be simplifying things, and I won't go into the actual models themselves for two reasons. One, the models are proprietary, and two, it's not a good idea for attackers to know how the protection is achieved. Perhaps the best place to start is using machine learning to detect unusual levels of activity. Citrix ADM has several models based on traffic, let's call them vitals. That is based on how much data is flowing in and out of an app, the total number of connections an app gets, the number of IP addresses is connecting to it, etc. And by constructing models, Citrix ADM is able to flag anomalies in any of these parameters. And each model, slightly different, understands the flow of traffic through your app. It creates a baseline and determines safe thresholds that indicate attack behavior. These thresholds are dynamic and adjust automatically with the seen and predicted traffic patterns as you would expect. Of course, when the thresholds are crossed, an anomaly is triggered and an alert is sent. And there are separate models for each item, for example, watching the number of bytes going in and out, the number of HTTP requests, the total number of TCP connections, and of course, things like the request rate, and there are many others. And they function independently, but the anomaly detection is similar. They use statistical methods to do that. The training period to construct the baseline varies per model, but once done, the dynamic thresholds can be set. And of course, that's different for each model. It sounds so simple, and of course, I've simplified it here, but there are some very complex calculations going on in the background, as I'm sure you can imagine. The example on the right shows schematically how a particular variable changes with time. You can see the daily variation as well as the gradual increase with time. And Citrix would train the model on historical data to create the baseline, shown as the solid line, and a prediction, the dashed line. Thus, when an activity occurs, represented by the white dot here, Citrix can confidently state that it's an anomaly. Now, despite the fact that it falls within the parameters that might occur, if you look at the day before, it's lower than the peak traffic there, but it matters about the timing as well. The level of the white dot is does not fall into line with what would be expected at the time of day, and that is the power of machine learning. Account takeovers are another use case for machine learning with Citrix ADM, and they're a growing threat for businesses today. Not only does a compromised account give access to confidential business assets, the threat of customer accounts being compromised also poses real problems. And more we hear of credential stuffing and password spraying attacks as bots try to gain access to accounts to access the valuable assets within or to resell cracked credentials. Now, whether it's a bank account, air miles, or hotel points, the individual is affected and dissatisfied. That's the customer. The business likely has to pay compensation, faces a good deal of brand reputation damage, and potentially very large legal fines as well. And Citrix employs machine learning techniques to detect exactly these types of attacks. And by training the model on, for example, the success and failure rate of historical login attempts, it's possible to identify outliers that represent an attack. Now, for the aspiring data scientists out there, this is done with isolation forest techniques. But for the rest of us, if you look at the failure rate in the graph here, you'll see that Citrix ADM is building up a solid picture of what typical login conditions look like at particular times of day and with season. And when variance occurs outside that, the Citrix machine learning engine can spot them and alert you. In this example, of course, it's pretty easy to see when an attacker tried multiple login attempts because it goes way above the failed attempts line in yellow there. Of course, this is an oversimplified representation, and there are a lot more mechanisms at work to detect outliers, but I think you get the idea. Another serious worry for businesses is content scraping. Now, we all want our sites to be visited and we welcome inquiries, but when a bot engages with your content to uncover competitive information like pricing to undercut you, for example, it's much more worrying. And worse than this, your important intellectual property, that is the site itself, with all of the carefully crafted search engine optimized content, can be stolen in an instant. At best, competitors will take your content and reuse parts of it themselves. But criminals may set up fake sites to resemble yours, hoping to siphon off your customers, or worse, commit outright fraud in your name. And this can be disastrous for a business in terms of lost deals, customer dissatisfaction, reputation damage. It can be also difficult to undo that damage. It's better to stop it happening in the first place. And Citrix uses machine learning to monitor user behavior on a site. When a person visits a website, either for work or to make a purchase, there tends to be a certain flow in terms of the actions they carry out. They'll go to the home page, they'll search for a product, go to one of the pages in the results of the search, and then they'll probably take a while to read about the product before they make a decision, and then they may put that item in their cart or go to another product. In any case, there is a pattern that can be defined mathematically to the visit. And by monitoring the time taken to search, the items viewed, the resources downloaded, Citrix built an entropy for all the visitors. And running these items through a clustering algorithm makes it possible to identify typical behavior and easily identify irregular content scraping bots. Because bots, of course, they're not going to be interested in the whole site. They're not interested in the JavaScript or the actual HTML content of a page, for example. It might just be interested in downloading the images or the pricing data. And the footprint they generate and the speed with which they do it will be very different. And the diagram on the right here illustrates how a single dimension can be used to generate a cluster and identify anomalies. But in order to ensure that you catch the bots and minimize false positives, it's necessary to take a multi-dimensional approach to the measurement and training of the model. So what does this mean for your approach to application security? Well, machine learning is a vital tool you should be using to secure your applications. With the growing reliance on applications across the business and the increasingly vulnerable application landscape, it seems to me that your application security requires every tool at your disposal. Machine learning, with its ability to process vast quantities of application telemetry quickly, will undoubtedly ensure you spot attacks on your apps faster. Its multi-dimensional analytical techniques will help you identify new correlations and detect irregularities that simply cannot be seen manually. I don't think machine learning will replace humans entirely anytime soon, but with the industry-wide shortage of cyber skills, it really is the only thing between your applications and the criminal. So the question is, can you really afford to be without it? And with that, I'll open up the questions and answers. So place your questions in the question pane, and we'll have a team of people coming to answer them.